There's also the opposite, where you have one compound and it decomposes into two things. Maybe two elements, maybe an element and another compound. It kind of depends. All right? They have one reactant and two products. These are very, very difficult to predict. So you really just have to memorize these, okay? So the first one is hydrolysis of water, right? If you run electricity through water, you can separate it into hydrogen gas and oxygen gas, okay? Now the other two are kind of related. If you have a metal carbonate, that's this one, right? Metal carbonate. Now I put calcium here, but it could be any metal. A metal carbonate decomposes into the metal oxide plus carbon dioxide. Okay, now I look through here, it's balanced, that's great. The other type is a metal hydroxide decomposing to a metal oxide plus water. Okay, now if you look at these, now the difference here is in the polyatomic ion. This is carbonate ion, this is water. Carbonate ion has most of what it needs to become CO2. So all you really have to remember is that both of these make the metal oxide. And then the other thing, you just kind of have to look. This looks like it could form a carbon dioxide. And this looks like it's all set up to make water. It's the kind of stuff that you have to look for. All right, next type of reaction. This is a single displacement reaction. It's also known as a single replacement reaction, where one element replaces a similar element in a compound. All right, so here's the first one we're going to talk about. There are actually two types. A plus BX yields AX plus B. So I want you to pause, write down in your notes what element is replacing what, and see if you can figure out what kind of elements we're talking about that's going to be doing the replacing. Okay, I'll give you a clue. BX is an ionic compound, all right? So is AX for that matter. So if you said that A and B are likely both metals, you are correct, right? A is displacing or replacing B. A comes in and it kicks B right out, okay? Kicks B out, B joins its own self, okay? And A becomes part of the compound. Now there's this kind, Y plus BX yields BY plus X, okay? Same thing, take a look, see if you can figure out what type of elements we're talking about. These, to me, look like they're gonna be nonmetals, right? Because these look like they're the anions in a polyatomic, in an ionic compound, all right? So the Y is gonna, this time, kick out the X, and X is gonna be by itself. All right, so metals displacing metals. Which type is this? It's the first type, right? Al plus, so this is solid aluminum, plus lead 2 nitrate reacts to form lead plus aluminum nitrate. So the aluminum is coming into this ionic compound and it's kicking the lead out. Lead just goes by itself, forms solid lead. Okay? So that means that aluminum nitrate is going to be the ionic compound and lead's just going to be by itself. All right, well, what about this one? Okay, Sn plus copper 2 sulfate makes what? Well, again, the astute of you might say there could be a couple possible products, because if tin kicks out the copper, we know that one of the products is going to be copper metal, okay, which is really just Cu. Okay. But what about the other one? Well, there's going to be some sort of mixture between tin and sulfate. Well, what kind of charge are we talking about here for the tin? Tin is a heavy metal, and as you know, heavy metals can have more than one charge. So I'd have to tell you what that charge is. So let's say tin Thor sulfate, just to make this interesting. Okay? So this is SN4 plus SO4 2 minus. Okay, I'm going to need 2 sulfates. So the compound becomes SnSO4 2. All right, now once again, I'll reiterate. Write the name out, get your compounds, then go back and balance. All right? I can't tell you how many times I've seen people who do this, tin 4 sulfate, and then instead of writing SnSO4 2, they just write SnSO4 because it balances so nicely. But that's not right. Okay? So now that I've made this, I have to go back and I have to balance. That's fine. I put a 2 to balance the sulfates, and I put a 2 in front of the copper to balance the coppers. No problem. All right. Now, the next type is group 1 metals reacting with water. Well, what? How does this fit our scheme? Okay. Well, rather than treating water as this covalently attached compound, what if we consider water to be an ionic compound, which is hydrogen hydroxide, HOH. Okay? Now you can see that sodium comes in here and displaces hydrogen. Okay? Now, I do form hydrogen, okay? Hydrogen, H2, and then my other compound is going to be sodium, and then what's left over? The hydroxide ion, sodium hydroxide. Okay? So group 1 metals and water will make metal hydroxides plus hydrogen gas. Here are a couple more examples. Halogens replacing halogens. Well, what type is that going to be? Well, that's going to be nonmetals replacing nonmetals. So that's the second type here, right? All right, so chlorine plus potassium bromide forms potassium chloride plus bromine. All right, so here the chlorine is displacing the bromide. Remember, bromine and chlorine are both diatomic molecules. But when they form ionic compounds, they have a charge of -1. So you have to be aware of that. You have to be picking up on these things.